Hey guys, so I've been out for a while here. I had a little incident. Had some really bad burns. So this has been running though in the meantime, but it's way overcharged. These batteries are like 4.4 volts per cell, I think, something like that. Yeah, 4.4. Like they're almost all like that. It's almost 4.4. Yeah. So I gotta stop this, and then I'm gonna have to. I'm gonna try to transfer the power again the way I've been doing it with the bridge rectifier, with the circuit, the batteries. I have it handy. Yeah, with this circuit right here. So my previous videos are showing this, just the bridge rectifier, but I'm not gonna use any meters because the amount of current is gonna be high. I have the meter that's on my battery back here. I'll be able to check it with that. And this battery's at, I'll have to charge this meter up too. I don't know how long I've been out for, but I got burnt really bad. 2nd-degree burns. So. Pretty sore. Shouldn't even be in here, but I have to get this done. So I'll parallel some bridge rectifiers up, some 25 amp bridges, the same as these ones right here. Put some big heat sinks and some big wiring, and I'll do that transfer. But that won't be today. I'm gonna turn this off and let them rest. So that's off now. Hopefully tomorrow I can get in here if I feel good enough to do it. But for now, they're gonna rest anyway. Hi guys, so I made it back in here. It's like 3 days later now. Well, I'm moving too fast. Like I said, I got 2nd-degree burns, so pretty sore. So that's this battery resting voltage now. And this one here hasn't went down much at all. Let's see. 61.3. Those cells should only be at 4.2. Surprising how much that circuit overcharged them. Because after 4.2 volts, they really convert a lot of it into heat. So, see, we're at 4.387 on that one cell. They're all pretty equal. .412, almost 4.418. So they're all like 200ths of a volt higher than what they should be. 4.42. So they shouldn't be anywhere. Shouldn't go over 4.2. So they're resting pretty high. That's 3 days of resting. And this one's 26.32. So what I've done here is I've taken two 25 amp bridge rectifiers, parallel them together, put a big heat sink, and put some decent sized wires here to handle the current. I think the weakest link will be my connections here, but Shouldn't be too bad. Get it going here, see how much current it's going to pull. I'm expecting it to pull quite a bit because of the voltage differences. That's why I've done it like this. And, oh, hard to move around. So here's that circuit. Minus the gauges there. This is the circuit. Now we're going to use to transfer the power back to the source. So I think there's going to be quite a bit of current here. I don't have any gauges. I'm going to put it through the shunt here and be able to see everything on here. And I'll get a thermal camera to take readings of the heat here. See where the weak spots are. This isn't reading it properly. There's no way. Definitely not the right current reading. Oh yeah, I wanted to take voltage readings of that. Be right back. Okay, 28.62. I think it was at 28.3 before I started here, and this is already, what, 26.45. So these current readings aren't right on here. There's no way. Showing milliamps when it's definitely amps. Actually, let me. Must have a 10 amp gauge here somewhere. I'll go find it. Hey, exactly what I thought. There's a lot of current going through here. I just tapped it there a couple times to see what it's at. So here's the gauge now. 10 amps. Maxes the gauge right out. Oops. Hook it up and just leave it go. Check out the heat on the thermal camera. This gauge is not going to be used. Don't need that. Okay. You're not going to work without the battery that's been connected. So it's right here. 2646. Connected now. 10 amps. Plus, probably closer to 15 or so. Should come down though. This was 57.3. Or 57.6 is what I'd like to bring it down to. Like resting. So I can go past that. The current here should drop pretty steadily. Just go get the thermal. Okay, I'll put you on the thermal now. Okay, here's the thermals. Ridge rectifier looks like it's the warmest. 65 Celsius. Pretty warm. Pulling about 6 amps. Wires are kind of warm too. A lot of that's reflecting though. I'm going to change the sensitivity. There. A lot of that, the stuff on the shiny parts is just reflecting. But those bridge rectifiers are definitely 67 Celsius. Not too bad. Everything else is pretty decent. But that's good enough for the thermal, just to get an idea. Okay, I'm just gonna leave this do its thing here. Take a while for this to go do its cycle. Sure, charging them hard though. Down to about 5 amps. I'll be back later. Hey guys, I'm just about to shut this off. It's been quite a while. I'd like to bring it down to 57.3 or so, but that's good enough where it's at. Current's down to about an amp. Battery's way fuller than they were before. I'm gonna let them rest and go rest. It's off. So this battery, you look back some of my previous videos, you'll be able to see what the resting voltage of those were. I think it was 28.4 or so. And this one I know was 26.35 resting. So it'll rest way higher than that now. And this one's already above. It'll probably rest around 57.8. Could have brought it down quite a bit more. So that's from overcharging them anyway. I should have came in here earlier, but it's pretty hard when you got second degree burns. I have to watch what I'm doing. I didn't think it was going to charge that much though. Kind of surprised me with these new diodes in there. But thanks for watching, guys.